I'm going to start the recording. Okay. Okay, we're going to continue with chapter 3 here. We're going to skip this section for benchmarking because we already more or less talked about it. Uh, Obviously, you're going to have different benchmark numbers now with YJIT. And also, I should mention that ZJIT was also merged into the Ruby code base, and it's possible that it will be another contender. Right now, YJIT is the default option, but there are other uh, efforts in place to also create alternative JITs. Okay. Um, so this last section was a little confusing to me.
Yeah.
Um, Local and dynamic access of Ruby variables. Um, I mean, basically, like it still has to keep track of these variables, right? So it's going to put the variables into the internal YARV stack. So that's what we see here. We have this variable that has the string local access uh, assigned to it, and so it's going to get put on that stack. Um, SVAR and CREF. SVAR stands for special variables. CREF stands for constant references. Um, and I am super confused about uh, like what this chart is showing about these special references. I think well in the text it says that special variables are variables that the YARV creates for itself to keep track of things.
Mhm.
Um, but then I'm not super sure about like why is there only one slot here, and does this point somewhere else or
I
uh,
think I was a little confused too. I think later in the chapter, and I think I took a note about this. So I took a note that it looks like SVAR is used when you're kind of in the scope of a method, and CREF is important when you're in like a block or lexical scope. So I think that when you're entering a method, you're getting an SVAR pointer to like a pointer to a list of SVARs. And I think when you enter a block, you're getting a pointer to this a CREF style pointer. The lexical scoping, I'm not 100% sure about that, but that was the impression that I got of why not only is there two different possibilities, but why it's only one or the other. And I think it's just basically two types of scoping.
okay.
Like the block and the method work differently. I guess that's the key. I think that the key is that block scoping and method scoping are they're handled differently, and so you get different pointers. And he kind of gives some examples when he does a little later in the chapter. He does the whole thing with the regular expressions or whatever,
Hmm.
and I feel like that kind of illustrates that idea that the block scoping is treated different than the method scoping.
Yeah, I have a question.
Yeah.
So is this a point at which now let's say a method is trying to access a variable that it shouldn't have access to. At which point is an error thrown for
Mhm.
that program when you're running it?
That's a great question. I think that that's not covered at all in this chapter. My
Well,
guess is it pops up in a later chapter, but that's a good question.
but it's the design of this makes it so that you're it's that's not really going to happen because it keeps all those variables in a different table and copies them when needed for a different context. But uh, you're never going to have those available, at least not, uh, I don't think. I could be wrong about this, but I
You
don't
know, I
think.
think yeah, I think you're right actually. So Newton, here's what I'm thinking now, considering what Nelson just said. I think when you have a variable that you're not supposed to access, it winds up being treated as a method. And I think that that is going to be completely different than all of this, than a local. I think like when you have a local, like a typo in a local variable, you get like no method error, right? Which I think is actually impossible to get through this specific mechanism. It must happen through a different mechanism that we just haven't gotten to yet, is my guess.
Oh, okay.
Yeah, I mean, so if you're not allowed to have access to it in Ruby, it means that it's out of scope, right? So
Mm.
it's a different place in code. And because it's out of scope, the variables don't get copied for this internal scope. So you're not going to be able to access them because they never got copied for this scope.
Yeah. Yeah, I think that's probably right. And I think Ruby will then interpret it as a method and not a variable as a result. But I think you can't, I think it's not available, like Nelson said.
Okay.
Okay, so it basically says that one of these, the zero, is another argument that gets wrapped into this set local uh, call. But for simplicity, he just rewords it to this, so it'll be easier to understand what's going on. Um, Displaying it like this means that you save an instruction because you only need to set memory for a single variable instead of two variables with this method call, but it's very, very confusing to look at, and it's super uh, internal to the details of how uh, Ruby or C Ruby is working internally. So he rewrites it like this, so it's easier for us to understand. And basically, set local to zero. Uh, this two and zero is basically going to tell um, Yarv where to look for this variable. So the zero means that it's going to be inside of this context, that you don't have to go outside of this context to look for it. And then the two means, oh, uh, sorry. And then the two means start from the current environmental pointer and go down to. So here we're going to start from this environmental pointer special, and we're going to go down to, and that's where we can find str. Um, and the value of str is local access. So I think it copies it to the top of the stack for use for
Yeah.
for this set local instruction. Okay. Um, so let's just skip to this next part where they're talking about dynamic access because we've already seen like this 2 0 means it's in this context. So let's look at uh, where it has to break out of the context. Um, okay, so here 2 1, it means okay, this is the current uh, environmental pointer. So in the previous case, we saw that it was 0. So it was inside the current environmental pointer. Now we see that it's 1. So we have to subtract 1. So the previous environmental pointer points to here, to this case. And now from here, we subtract 2. So we go down to str, and then we copy the value of str to here, to the top of the stack. So because like to get back to what Newton was asking, because we should have access to that variable, we are going to copy that variable to our current context. If we didn't have access, or if we shouldn't have access to that variable, it will never get copied. And so you just can't address variables that you shouldn't be able to.
Yeah, I think so. That makes sense.
Okay, so I mean, basically, it says, okay, now we're gonna have a block inside of a block, and now instead of 2, 1, it would be 2, 2 because we have to go out 2 blocks and then down 2 entries in the stack pointer to get the variable str. Okay, so climbing the environmental ladder in C. So this is the actual C implementation of get local. And basically we see here that we have those 2 numbers, right? And the first number is we're going to call get previous environmental pointer for one of the numbers, you know. Um, so we're going to loop through until we get however many environmental pointers back we want. And then once we have the environmental pointer, then we just uh, subtract the index from that environmental pointer. So like we saw previously. Um, I mean, that's what's going on. I don't know what else to say about it. Um, so
Yeah, me
this,
neither.
yeah. So exploring special variables. So this is the SVAR and the CREF things that we were looking at before. It gives some certain examples. We have fox.match, um, and then dog.match, right? So fox.match and dog.match are 2 special uh, variables that are going to get created and put on the stack. Um, and the details of all of this are super fuzzy. Like I explained, this section was confusing to me. I know that they get created. I know they get put on the stack. Uh,
Well, I think that might be part. I think what might have helped with the confusion, I guess the author just didn't have enough real estate on the page. But I was actually thinking about the same exact thing. I wonder if it might have been helpful if they showed, there's just not enough room, I guess, but both stacks and the tables that are being pointed to. Like he doesn't illustrate what the special variable table looks like. But I'm assuming that SVAR is a pointer to a table, and that table is being updated at runtime. But he doesn't actually illustrate that table. And I think that might be what's causing confusion. I mean, I'm not certain about that, but that's how I'm picturing it.
okay. Yeah, but
Meaning it doesn't go on the stack. Oh, actually, here, he does have a table. Yeah, so you can see that the SVAR is pointing at an external table that's being updated
oh yeah,
independently.
you're right.
Yeah,
It
yeah,
is
yeah.
another table.
Yeah.
Uh
That's it's confusing until you see it though. So,
yeah.
yeah.
And even the first time I read it, it didn't click. Okay.
Yeah, because he's actually showing the table kind of as an array because it looks like it's position based. But I think a table would have been less confusing, but it's probably not implemented as a table. But yeah. Yeah, yeah, yeah.
Okay. So I mean we're executing the code. We're keeping track of the special variables. We're putting those special variables uh, in the same um, call stack as the internal YARV instructions or whatever variables. Um, okay, this I, I mean this is a lot of detail. A definitive list of special variables. So in the C code, he tells us where we can find this. But I don't know what how this helps me. It's a lot of detail. We can find the thing that we so the dollar sign ampersand is the last match. So that's what that's why we have the dollar sign ampersand, which was the last match. Um, I mean, I guess it helps for performance reasons. So that you can just if you have this case happen again, you can just look it up from the table instead of calculating it again. Um, but that's the only reason I can see to keep track of them, all of these special pointers.
It's kind of, I think, I'm not 100% sure about this, but I part of this is like inspired by Perl. Um, sometimes I see linters that actually don't let you use these special variables. I don't know if you've seen that before, but there's actually other constants and stuff that you can and method calls you can make instead of using the special variables. I personally use the special variables because I've been used to them for a long time. One thing I think is really confusing about them is they start with a dollar sign but are not global, which he mentions in the text. Um, and that's kind of confusing because you kind of get used to seeing that dollar sign and thinking, oh, this is a global variable. But these start with a dollar sign and are not global because they're constrained to these tables. Um, so yeah, it's kind of a weird, interesting concept. I do make use of it, but some people forbid using the special variables with a linter,
Okay.
and potentially because it is confusing. And I mean, because like if you
It's
think about, yeah, like dollar sign ampersand is not, it's like it's not self-documenting code, if that makes sense.
right.
Like dollar sign ampersand only communicates something to you if you've already memorized what that symbol means.
Yeah, yeah. It's very, very difficult to remember what they all are and what
Yeah,
how to use them correctly.
yeah.
Okay, but so then it was just the summary of the chapter. Basically, we took a look at the different stacks and the YARV internal stack and also the control frames and how they work. And then we they took a look at the special variables and local and dynamic variable access. And that's more or less the end of the chapter.
Yeah, so I have a few questions.
Hmm.
Yeah. So last time, I don't know, Nelson, if you remember, when we were covering chapter two, which is the one that introduced the YAV implementation and what YAV does in the
Yeah.
context of executing of the code. So I asked this question, and the question was along the lines of what was the reason of introducing the virtual machine? And he told me the answer to that was for performance reasons. Yeah, I don't know
Hmm.
if you remember.
Well,
So my
it's way faster. So yes, I know the question you're going to ask, but so the first chapter describes lexing, and remember in lexing was hard work. We did a lot of things in lexing. And
yeah
so we did we go through each character and we parse what type of thing that character is. Okay, so this is a 1, this is a 0, this is a decimal point. So this could still be part of a let's say a floating point number. We go to here, we find a letter and we say, "Oh, we found a letter." So this must not be a floating point. This must be this must be an integer, and this is a method call,
yeah
and so that all of that tokenization uh, gets has to get done, and then it has to go to the parser, uh, and the parser turns it into the abstract syntax tree. And because we have a virtual machine, it means that you can take that abstract syntax tree and run your code way faster by using that abstract syntax tree instead of tokenizing every single time you want to run your code. Okay, now I'll let you finish the question. Sorry.
Yeah, that was my first question. Now
Yeah.
my second question. So there's MJIT, yeah, there's ZJIT, there's YJIT, like so many kinds of just-in-time compilers.
The only one you really have to remember is YJIT. That's
Yeah,
the one that's being used.
yeah. So my question is this. Why can't all these guys just agree on the fastest compiler and they use that instead of like I know it's like a very like naive question, but why can't they agree on one thing and they use that because it's the fastest. So why can't they just use that?
Well, MJIT came out first and it wasn't the fastest. MJIT came out first and it slowed down Rails. And so it couldn't be used in Rails applications. So a company, Shopify, said, okay,
Yeah.
we want to make our Ruby code go faster. We use Rails in production. So we're gonna uh, we're gonna speed things up by creating YJIT. And then ZJIT is a different thing. And the goals of ZJIT are, I think, a little bit different, where uh, the ZJIT, I think, is more along the lines of um, running experimental compilation steps and finding ways to speed up your code um, even faster through like an open um, well, I don't know. Maybe I shouldn't talk about it because I'm super unclear about it. So maybe I should just say I don't know why. And but ZJIT is another contender, and they're trying to do things differently uh, than YJIT.
Yeah, I'm familiar with the widget thing because I saw some post and they were saying that Shopify was doing like I think 1 million requests per second that time when they do the Black Friday thing.
Yeah.
So maybe that's the reason it's like the fastest. But yeah, that was my question. Like, why can't they all agree on one thing and use that?
Yeah, I feel
Yeah.
like that's pretty common in software. Like sometimes something will just be a passion project. Sometimes different people are concerned with different things, like solving different kinds of problems. Uh, yeah, so I think there's multiple reasons why you wind up with multiple projects. And it doesn't seem specific to just-in-time compilers for Ruby. Like I feel like all software is kind of especially like open source software, there's always like a lot of alternatives out there for various reasons, I think.
Yeah. So I have another question, but this is mostly because Nelson talked about the whole performance thing and yeah. So what I'm understanding when you're trying to like increase the speed of your application is now let's have a Rails application. So I might start out with things like maybe refactoring some parts of the views into partials. And then after that, if that still hasn't increased the speed of the application, I now go maybe to the database. And then I optimize some queries in the database. And then after, if still that doesn't improve the speed of the application, is that the point at which I go now to the layer of Ruby and try to optimize at that point? Oh,
No, the first option for optimizing should always be any network thing that you're doing. So the database calls. Um, the okay, let me see. Um, I have numbers everyone should know. Okay, so Um, these are the performance of the different things in your computer and the network. So these are the things that are going to be super fast, are going to be your CPU. Anything happening, anything that takes one instruction in a CPU cycle, which means like these days it's an addition. Like one addition is a single CPU cycle on Intel processors. Um, Level one cache. If so, and inside of these, inside of the CPU, you also have registers. So if you're going to be adding between two different registers, that's one CPU. That's super fast. A layer above that is level one cache. Level one cache is a type of memory that is very, very fast. It is attached to the CPU and it is there. Um, eh, each uh, core in your CPU will have its own level one cache. And but because it's super fast, it's also very, very expensive. And so you're not going to have a lot of it. So you have a level one cache. Then you have your level two cache, which is going to be a little bit slower, still pretty fast. 3 nanoseconds is very, very fast. And then you're going to have your level three cache, which all these caches are still directly attached to the processor, and they're all a little bit slower than the last. Then you have main memory access. So we go from level three cache, which is 28 nanoseconds, to 100 nanoseconds uh, which is your uh, RAM. Then here, I mean, it doesn't have drives, but if you're accessing anything from a file, that's going to be slower than RAM. And then for the network, if you have very, very, very fast internet, it's going to be 20,000 nanoseconds, which is a whole lot slower, which means that if instead of sending a single network request, sorry, instead of sending 100 network requests, you can send a single network request. That's going to speed up your application by a lot because anything you do to speed up instructions on the CPU bound instructions, that's not going to get you a lot of time. What's going to get you a lot of time is speeding up anything that's happening on the network because anything that's happening on the network is going to be multiple times slower. And actually, this gives you a better idea of how much slower. So if one CPU cycle is 1 second, then one network request, uh, so internet packet from San Francisco to Europe is 10 years. So you're talking about like, oh, I'm going to gain 1 second here, 10 seconds here, and all those things are, real. You can get that time, and that's going to speed up your application, but not by that much. If you concentrate on the network things, hey, you can shave years off of that execution time.
Okay. So yeah, those are my questions. I don't know if you guys have any questions on your end.
I had some, but I feel like they're probably going to get answered in later chapters. I'm like curious, you know how like in Ruby's like pretty dynamic and you can override methods. Um, and we saw like the dot times method that it calls out to a C function, they optimized it by implementing a C version of it. Like what I'm curious about is what happens if I override dot times? Does it does like YJIT now start tracking the brand new method and eventually um, we'll compile it to the virtual machine bytecode?
Yeah, it
And
does.
Yeah, so I have like questions like that, and how does it know? What does it do with like any like? I guess I'm kind of just curious when I'm like changing things at runtime. How complicated does the logic inside the virtual machine have to get to like get the benefits of all this compilation and caching and stuff without um, uh, making it difficult to do all the crazy dynamic programming techniques you can use in Ruby. So I'm kind of
So
curious about things.
I did hear someone ask a question along those lines to one of the authors of YJIT, and the answer that he gave was basically if you're starting up your application, any sort of if you're doing any sort of overriding of you know uh, basically if you're doing any monkey patching, you should do it as early as possible.
Oh,
Because
interesting.
if you do it as early as possible, it means that um, it means that YJIT won't have compiled your code at that point. If you wait and the code is running and you monkey pile at some later point, what YJIT has to do is say, oh, this method is different or this class is different in some way. So I'm going to decompile or I'm going to remove the compilation that I previously did. I'm going to run and I'm going to have to recompile the new code. And obviously paying having to decompile and then recompile is a cost.
Okay. Yeah, that makes sense.
Do you want to lead next week, Miles?
Me? Oh, yeah, I'm happy to try that if you would like me to. Yeah, I could give that a try.
Okay, that would be awesome.
Sure. Yeah. Cool.
Yeah, so I think this is it really. We are done with
Yeah.
chapter 3. So next week will be chapter 4, and Miles will be leading as agreed upon. Yeah, so
And thank you, Miles, because you actually cleared up some points for me, and where I was confused in some places, and you had more context for me.
Yeah, I think it's confusing material. I'm still confused about some pieces, but yeah. Yeah, but cool. Yeah, my pleasure.
yeah.
And I learned a ton of stuff too, actually. So, yeah.
So yeah, you guys have a great